Okay, section 5.1 is on page 356. Talks about area between two curves. Let's say I'm looking at some graph of y equal some f of x. And let's say there's another function, let's say g of x. And assume I would like to find the area between those from x equal a to x equal b. So basically, I'm after this region. Now, a couple of things you have to really make sure of, and I'll point that out as we do more examples, but from the beginning, if I am to look at the integral from a to b of f of x dx, from what I know, this is going to find, from the x-axis to the function, it's going to find me all of that area. If I integrate from a to b, g of x dx, do you see that this is going to run from the x-axis, but that's going to be negative? Since in this section we're finding the area, if I put a minus in front of it, that'll work. Since those limits are the same, I could say from a to b, since that's dx for both, and can't I say that is f of x minus g of x? So an easier way of doing this is for me to actually draw, if I'm talking about dx, a delta x is on the x-axis, draw a small rectangular piece, call it delta x, and take the top, which is f of x, minus the bottom, which is g of x, regardless. So instead of going into the cases, case 1, case 2, case 3, this will work on all of them. Make sure that between a and b, the top of the function is identical. It doesn't change. It's always f of x. And the bottom of the function is always the same function, and that is g of x. So when I get to problem number 2 on page 362, I notice that, whoops, went too far. If I draw my rectangles, and the whole section is going to be based on that, if I draw my rectangles vertically, that means delta x. Well, then area, it says find the area, is going to be the integral. And let's see. If I'm running delta x, it has to be x equal to x equals 0. And it seems x is 6. And if I glance at that, do you notice the top equation is always the red? Isn't the red always the top? And that is 2x minus the base. Minus the base. And isn't the base the parabola on this interval between 0 and 6? And the parabola is parentheses x squared minus 4x. Now I'm going to set up the problems. I'm going to integrate, assuming you can integrate that. And if there's a problem that I set up and you can't integrate, you ask me during class discussions, I'll be more than happy to go over that. I get to number 4, and on number 4, I notice there's a problem. And the problem happens, if I run this vertically, we have a problem. Here the top is the blue and the bottom is the blue. Past this line, the top is the red and the bottom is the blue. Past this line, the top is red and the bottom is red. Well, I could do that problem that way, and we're going to do that on certain problems. But if I think about it for a bit, wouldn't it be easier if I looked at this sideways? And why is that? Well, vertical, you take top minus bottom. Sideways, you take right minus left, always. Do you see that if I run this, first of all, that's delta y. Area would be the integral. And since this is a dy, it's going to be from y equals 0 to y equal, that's a 3. And in this case, I'm going to take right minus left. That is, the right function all the time, the right function, isn't that this curve? And this curve is x equal 2y minus y squared minus the left. And isn't the left the blue? And the blue is always, you know what, I'm going to move all of this down so I could have a bit more space. And isn't that going to be in parentheses y squared minus 4y? So something to start paying attention to. Something that we normally overlook. Notice if I am having a dx, then this is y equal, because if this is a dx, you want only x's in there. If this is a dy, this is what x equal, because you want a function of y in there. You can't integrate dy and there's an x in there. You can't integrate a dx and there's a y in there in this class. You'll do that later on, but not for now. If I look at, and that's pretty much the entire section, if I look at the next problem up, if I look at sketch the region enclosed by the given curves, decide whether to integrate with respect to x or y, draw a typical approximating rectangle, label the height, the width, then find the area. Well, let's see how this works. Y equals sine of x. I know that's a graph that's bound between 1 and -1, right? So if this is 1, this is -1. The graph of a sine wave starts at the origin, runs up to the amplitude, back down, and back to the starting point, and it looks okay, something like this. Y equal x 0, 0. When I get to pi over 2, right? Pi over 2 is 1.57. Y is 1.57. So I notice that the line is definitely above this. And I'm running this between x equal pi over 2 and x equal pi. So kind of off. I'm talking about this area. I'm not sure I have that there. So if I want to find the area, I wouldn't say the area. Obviously, dx is the way to go. Why do I say that? Because if you run sideways, do you see here? The right is the line, the left is the curve. Past this point, the right is the line, the left is the line. And here, so you need 3 integrals to do that. We will do that later on. For now, we're going to do things the simplest way. I'm going to draw my rectangle vertical. I notice the top is always the line. So that's going to be, the top is the line that's x minus. And the bottom, I notice, is always the curve. The curve is the sine of x. That's, of course, I should have wrote a dx first, but I just wanted to fit nicely. The spacing, that is. And there it is. And that's how it works. All right? Again, I assume you could integrate that. If you can't, ask me in class. I'll be more than happy to do it. So here you're going to have to show a bit of your graphing techniques. Right? And how about right here? If I want to look at this, this is a parabola opening up, centered at 0, x equal 4, 1, 2, 3, 4. Since it opens up, well, something like this. If I need to know exactly where that vertex is, I could. 2 ways. Either I complete the square or use calculus, take a derivative to figure out the minimum. Y equal 2x, 0, 1, 2, 1. So it's a line that runs like this. And obviously, this is going to come out. You know what? Let me rescale this. So let's say this is 1, 2, 3, 4. So the parabola actually looks something like this. And y equal to x, 1, 2, 1. So there it is. We're talking about this area. Well, again, it seems vertically is the way to go. The reason for that, the top is always seems to be the line. So the top is always the 2x. And the base is always looking like the parabola. If I run from 0, I'll get where that point is in a minute. and this looks like it's going to be at the x, and the parabola is x squared. Make sure to use parentheses. And how am I going to figure out where those intersect? That's where algebra comes in. That's when you take x squared minus 4x, set it equal to 2x, x squared minus 6x equals 0, x into x minus 6 equals 0. So this is 0 to 6. There it is. On the test, when I say set up, do not solve, that's all I want. And if I run to number 12, x equal, well, it's really x equal negative y squared over 4 plus 3. If you're not comfortable with that, I suggest you look at y equal x squared over 4 negative plus 3. Wouldn't you say that's up 3 units? So 0, 3, 3, 0. And some number positive, negative, well, that's something like this. Again, the reason I'm not picky about exact, because I just want to figure out which is which. It's not going to matter how accurate the graph is in this case. If I need to, I could figure out exactly where those are. But you know, we don't need that. So how does that work? I want to find the area of this region. Well, in this case, do we agree that I'm better off running sideways, not vertical? And sideways, that would be area equal the integral. This is how you should start writing this. It's a delta y. And it's going to be right. And the right, isn't the right function always negative y squared over 4 plus 3 minus the left? Isn't the left the line? And isn't that y equal x? Oops, x equal y. Look at that. I was just going to say be careful. And how am I going to figure out where those equal? I'm going to take, in terms of y, replace x by y. That's going to be 4y plus y squared equal to 12. Y squared plus 4y minus 12 equal to 0. Y plus 6y minus 2 equals 0. So this is a negative 6 and this is a 2. From negative 6 to 2. And that's all the work you have to show me. And if I look at this last problem, y equal the cosine of x is a graph that looks like, and I'll eliminate those in a minute. Cosine starts at the amplitude, runs down, back to the starting point. It looks like that, right? So pi is right there. And y equal 1 minus x, you go up 1 unit, a unit above and a unit below. Cosine starts, it's upside down, so it's going to go up. No, I messed up. You start y equal 1, you go up 1 unit to y equal 2, and down 1 unit to y equals 0. Starts, it's upside down, so it starts down here, goes up, and back down. And I want the area between 0 and pi. Well, I notice there's no way of doing this one shot. So I'm going to have to run, and I'm looking at this area and this area. Well, here, wouldn't you agree that the top is the cosine and the bottom is the actual 1 minus cosine of x? And that's from 0. And where does cosine of x equal 1 minus cosine of x? That's when cosine of x, twice of those equal 1, or cosine of x equal 1/2, that is pi over 3. This is pi over 3. Plus, I'm going to run from pi over 3 all the way to pi, and here I could see that the top now is 1 minus the cosine of x, minus the base happen to be the cosine of x dx. And that's how it works. Alright, and you could integrate those, and that's the answer, and there's the homework.